Okay. Hello to all of our viewers. Thanks so much for tuning in to our webinar tonight. My name is Liz Eggleston, and I'm a co-founder of Course Report, which is a resource for researching the coding bootcamp that's right for you. And if you haven't checked out Course Report yet, you can use our directory to find coding schools that fit all of your needs, and you can check out our blog for unique content like interviews with students and instructors and founders at all these bootcamps across the world. And we've also got this great webinar series where we give you the opportunity to get some valuable information straight from the source and to ask questions that you might have for people in the bootcamp industry. So by now, I think that most people are familiar with coding bootcamps, but at Course Report, we love seeing this bootcamp model sort of applied to other subjects, and one of those is data science. And there are a couple of boot camps that teach data science in the US, but most of them that we've seen are only for PhD students. So when Metis sort of announced that they were going to have this data science course, and I found out that you didn't need a PhD in order to attend and actually get a job as a data scientist, I knew that I had to learn more, and I'm sure that y'all are really excited about it too. So if you know about Metis, they're live in Boston and New York, and at Course Report, we're consistently impressed with their partnerships that they've chosen. They partner with Thoughtbot for their Ruby on Rails bootcamp, and they've partnered with this awesome data science consultancy called Datascope Analytics for their data science course. So tonight we are joined by Irmak and Laurie Skelly from Datascope Analytics. And Laurie and Irmak have actually created the curriculum for this Metis course, and they're going to be the teachers in the course, so who better to really talk about their experiences. So we're so excited that they've joined us. And I want to remind everyone that we'll be doing a couple of Q&A sessions throughout the webinar. So please use the questions tab, the Q&A app in Google Hangouts, to send in any questions that you have, or you can tweet us also. Don't be shy. I've had the pleasure of getting to know Laurie and Irmak over the past few weeks, and they have so much amazing knowledge and experience, so you definitely want to get those questions in. So with that, I'm going to pass it over to Laurie and Irmak, and they're going to introduce themselves and tell you about their roles at Datascope.
Sure. I am a partner and a data scientist at Datascope. My background in bachelor's was materials science and engineering, and then I did a PhD at Northwestern on chemical engineering. But it was mostly complex system analysis, which is kind of like data science using physics tools and statistics tools to a lot of different systems. So that's where I sort of got familiar with the data science and playing with models with completely different unrelated systems. And now at Datascope, we all like to wear different hats. All of us are data scientists, and we talk to clients and try to figure out their problems and develop and design algorithms and solve them. That's basically what I do now.
And I'm Laurie Skelly. I'm also a data scientist at Datascope Analytics. My background was in social neuroscience. So I got, from high school, I wanted to study brains, and then by the time I finally got my PhD in it, I was kind of tired of it. So what happened was I was at the end of my academic career, and I loved certain parts about research and doing quantitative analysis and starting with questions and ending with stories. But there were certain other aspects of that career path that I just wasn't interested in anymore. So I found out about data science, and I have been at Datascope for almost a year and a half now. And a lot of the work that we do here feels really familiar from kind of the arc that we did in science. So we'll start out wanting to solve a problem or to answer a question, and we'll have interested parties that want that problem solved. And then from there it gets extremely complicated for a while. My dissertation was looking at brain networks that underserve empathy in incarcerated criminal psychopaths. So there's all these different brain networks that control the different components of empathy, and the idea that some of those might be not working well or not working together properly, and that contributing to these people who commit crimes. So there's this question that impacts society, and then in order to carry it out and make new insights about it, we scanned a lot of brains and did a lot of modeling. So coming into data science, I see a lot of parallels, and a lot of my technical skills carried over. There's a lot of new things that I had to learn, and I think that that's something that I see a lot in people who want to make a switch from academia, whether it's from a PhD program, if they're finished or leaving early, or a master's. It's just like, what's different and what's the same from what I've been doing before. So that's been really interesting during the development of this course.
So cool. Y'all have such neat, varied backgrounds. I love it. For anyone who's just joining, because I just noticed that we got some new viewers, we're going to do a couple of Q&A sessions throughout the webinar. So just use your Q&A app and ask any questions that you have, and we'll get them to Laurie and Irmak. So data science is a relatively new field, probably, you know, has cropped up in the last 10 years, and even a new job title. What would you say is the difference between a data analyst, a data science, a data engineer, all of these roles that we're sort of seeing, you know, on job pages?
I think that this is a question that comes up a lot, so I'm glad we get to talk about it. And I think the most important thing to remember is that these are conventions, and the conventions for these job titles are evolving. Like, there's not like a precise definition for each one of them. So we know that a data engineer is going to be in charge of keeping the data stack, and they're usually involved with really big data and having, you know, the newest, fastest way of implementing algorithms. And so it's kind of on the operations side of data science. Then on the other side, there's kind of data analysts. So if you're in a big company that has a data science team, an analyst might be finding ways to answer questions, finding ways to go at a particular goal for their company, and usually they have like a lower burden of coding. And that like really varies too. So I can't say analysts don't have to code, because some of them do tons of coding and some of them do zero, or use, you know, little scripting languages, or do like macros or something like that. All sorts of programs are out there too. And then data science is kind of spread out from overlapping with data analysts all the way to overlapping with engineers. And some positions would ask people to do everything, and some people have like a smaller slice inside that like spectrum of responsibilities.
Right. These are just guidelines right now. Nobody knows exactly what any of this means, including people that are hiring and people that are applying for these jobs. So it's basically a spread of skill sets that, you know, people refer to with these, and, you know, the guidelines that Laurie explained sort of like are the different poles of it.
Mm-hmm. Y'all talked about working on a team like in a big company. Can you talk about the different roles, what it sort of means to work for a company versus working for a consultancy as a data scientist?
Sure. As you can be a data scientist under like different concepts. There are a lot of companies like Facebook, LinkedIn, Groupon, who have data science teams. That's usually like a team with a project manager on top, where you come up with a project, or the project comes down to you, and you're trying to solve that as, you know, everybody goes through the problem and attacking like how to solve that. Now, there are other companies where they have more classical statisticians, and they want to sort of employ the power of data science, you know, at the more programmatic way of like approaching the problem. So you might be someone that's supplementing the statistics team, or trying to come up with, you know, projects by yourself. Now, there are consultants companies where they come in and help a business either with their data strategy. So the businesses don't have data scientists, the consultants don't know the domain that well, but then so the difference there is that if you're actually working in the company, you're way more familiar with what goes on in the company. If you're a consultant, if you're a data scientist at a consultant company, then you come in and you try to learn their knowledge, and you try to supply your knowledge about your skills, and together come up with a solution to their problem.
Oh yeah, go ahead, Laurie.
There's one other like really neat kind of distinction that I've heard a lot about too. And some teams are tasked kind of with like doing projects like for the company, like how is our company doing with this, and like what are our customers like, what are our users like, and what is our product like, what is sales like. And there's like a special case when you're at a company that makes like a technical product. So there's like a data analyst team at Etsy. They have a data analyst team that is doing more stuff that's like reports for the company and what are creative ways that they can learn about how people are using Etsy. And then there's a data science team that is like part of the product team. So they're putting things into the product that have to do with data science as well, like recommendation engines or like how the cart works and things like that. So that's another way that you can break it down.
Yeah, last week, for anyone watching, last week Metis did an event in New York and had the Nell, the woman who runs the data analyst team at Etsy, come talk, and it was awesome. And it's also recorded and online, and I'll send out the link afterwards if people want to watch it. It was pretty neat. Okay, so what are the sort of basic skills that you need to have, technical skills and soft skills, in order to be a data scientist, now that we've sort of established that you don't have to have a PhD in order to learn the skills that you need? What are those skills?
I'd say from a technical perspective, you need to, of course, like retrieve clean data, handle it. So you need to know, some databases or web scraping APIs, ways of gathering that data. You need to be familiar with statistical analysis, probabilities, distributions, estimating, sampling. You need to know, machine learning, classification, clustering, regression, that kind of thing. With visualization, you need to know both how to design and how to convey your ideas well, how to show your results well. So both the design aspect is really important, and also, of course, technically you need to be familiar with the tools to create those visualizations, kind of like an example is the D3.js library, JavaScript library. But even more important than any of that is what you refer to as, I guess, soft skills, is designing and continuously communicating throughout the project. The idea is a complete, continuous brainstorming of ideas, and the most important thing is, of course, knowing the why and defining the problem. Clearly, defining the problem is a way more difficult thing than it actually usually seems. So there needs to be a lot of figuring out what you need to answer, and that is never a simple answer that you find at the beginning of a project. It's like a complete, continuous, iterative feedback process where you try to answer it, you communicate, you try to understand the results, and you get feedback from that, either if you're consulting someone, either from the person that has the problem, or if you're trying to solve your own problem, you understand your question better and new questions pop up. So it's this evolution, and the most important skills with these are, being creative, I guess, curious, being able to communicate your ideas well, and being very open-minded to outside opinions so that you can build on them.
Yeah.
When you say being creative, do people need to have like design skills? Like sometimes when I think of data science, I think of like infographics and just like ways that people communicate and like that, in like sort of neat ways. Like, do you find that you need design skills or not really?
Well, I mean, it really varies on what kind of job you want to do. If you have designs, if you have kind of like aesthetic creativity, there are like numerous ways to find an outlet. But if you don't be discouraged, because we actually mean a lot of different kinds of creativity, or like a kernel of creativity. And it's kind of more what has to do with problem solving, or sometimes I think about it as like being a little bit of like a hustler, You're like, I just got to get the job done, and someone said no about this, and I have to figure out a different way to do it, So it's kind of just that, whatever it takes, I'm going to find a way to get what we want in this project done. So we doodle a lot here. Like, I'm just looking out at the walls that are covered with doodles, and some of us are very good doodlers. Some of us, they try hard, but all of us are really creative when it comes to like coming up with ideas and how are we going to attack a problem.
Very neat. At Datascope, how large are the teams that work on individual projects? Does it depend on the project, or do you try to have like people with different skills on a team? Or?
It depends a lot on the project, of course. It varies from 2 to 4. What we like to do is actually teams can sort of like swell and shrink over time sometimes. Like it's not these 2 people are working on this and it's completely solid. We like to jump in and out like as necessary as the project necessitates, and especially in terms of that design process of brainstorming and coming in with ideas. We like to use as much of the entire team as we can, so that we can empower all of our ideas. And pair programming is an important aspect for us. So it's usually 2 people programming, then it's maybe 4 people pair programming. Usually teams of like 2 to 5.
Yeah, we're fairly unique here too because we're a pretty small consultancy, and we really we're kind of hesitant to give up any piece of the project. So it's pretty uncommon that a data science team would do all the things that we do, from kind of business development to web development. But we really we like it a lot. So and like what Irmak was saying about the expanding and contracting, like we'll all come together for kind of that brainstorming part, but then sometimes the coding part, or we'll split it up into little pieces. And it's really different from place to place. I think we're pretty unique here.
Got it. Very cool. Okay, so Laurie and Irmak, y'all, that's a great introduction to data science, I think. But if y'all could give us a little bit of more of like a deep dive into what your job really looks like on a day-to-day. If you could talk us through a project that you've done with Datascope and the dimensions that go into that project, we would love that.
Sure. So we did this project, for example, for a legal company. So when Samsung sues Apple or vice versa, right? They send each other like a lot of documents. All the emails they have, all the reports, it's like thousands and thousands of documents. And somebody has to find all of the documents that are actually related to this court. And only lawyers are authorized to do that. So, full-on lawyers are just reading all these emails between friends and saying like not relevant, not relevant, not relevant, relevant. And this costs a lot because, lawyers cost a lot. So we built a tool that automates this, that basically looks at the documents and finds the ones that are related to the case, to the court.
Yeah, so this is called discovery, right, in general. Mm-hmm. And in particular, we're talking about the process of e-discovery, which is a pretty hot topic in kind of like machine learning field. And when I saw e-discovery, I kind of assumed that it was already automated, right? But it's not true. Like the E just means that it's for electronic documents. So it's things that you could automate, but that's not what's going on. It's actually a more difficult problem than it would seem to be able to automate this email thing, because the concept of what's relevant to a case is really difficult. You can't just do a keyword search, because you might call it that thing where we're embezzling all the money in one email, and you might call it Project Acorn in a different one, or what have you, right? So it's really a kind of complicated problem, and it's been really not possible in the past, by the time we got this project, to do it in an automated way that was admissible in court.
Mm-hmm. And I mean, so when we first built the tool, okay, now it's actually identifying them. They couldn't use it immediately because the judges didn't trust the machine. We knew that it was working well, but the judges were like, well, this is not coming from a human being. I won't trust it. So we needed to prove that it did just as well as a lawyer. So we built this interface where, the whole idea is that actual lawyers will start doing their discovery, and the machine will learn from it and start doing it on its own. So we built this interface where they could immediately see the actual accuracy of how the machine was doing, so that, and of course, while they're contributing more and more data by doing discovery themselves, the machine was getting better and better. So they would know exactly at which accuracy they are. And actually, pretty fast, the machine was doing much better than lawyers, because it's actually a pretty difficult problem for a human being too, because you're reading like tons of emails that are completely unrelated, and there's one in there that easily slips by, but it's critical actually. So this is sort of like how the project went. So sorry.
Yeah. Oh yeah. No, I think we love talking about that project because it's such a good illustration of all the pieces that go into a data science project. So we had the problem space, and we came up with some initial solutions of how can we use like machine learning, and how can we automate this process of finding these relevant documents. And then we had like a further design challenge. You know, it was actually like, wasn't it it's like a burden that you have to prove to the judge and to the opposing counsel, so that what you're doing is legitimate. So we had to come up with a model that was complicated enough to actually work, and then find a way to express it in really simple terms so that everyone would, you know, look at it and be like, oh, okay, this seems above board. Yes, let your robot e-discovery thing, that's fine. And so, I mean, that's a problem that we really, really love, because it's one thing to just, you know, minimize the error, but it's another thing to like make something that's actually really useful that people can take in and I mean, if you think about just like lawyers, like people who went to law school, like sitting there, like reading email after email, like how much like the like hourly billing just racks up. And by the end of the project, we were able to reduce the number of documents that had to be reviewed. I mean, the final solution was not totally automated, but it got rid of 99% of the search space. So the lawyers just had to look at 1% of those documents and say, oh, this one, and as they continue to train it, which is just like an extraordinary savings.
That's amazing. At the end of the project, did you feel like the lawyers that you were working with really trusted it, and like that you had been able to communicate that to them?
Yes, definitely.
Yeah.
And I can sort of describe, you know, when you think about it, so the part of the design problem is evolving around that question of like, will you be able to communicate this well enough so that they understand what's going on here and they trust what this is telling them? And in terms of sort of the tools that we had to use, like for the documents, we use, you know, some databases like MySQL, HDFS, I think, like distributed databases. In terms of, you know, algorithms, we used LDA, a topic finding algorithm, to understand what topics are in each of these documents. We use a Bayesian classifier to do all this like classification. And then to communicate all that through the interface, we use a Django web app. Basically, you can see like there are all these like totally different tools that we use. And then how we were actually applying all this, like from the beginning to the end of the project, like what was going on in a day of, you know, Datascope, is one day there's completely this brainstorming and talking about, okay, how are we going to show this? We're making doodles. If I saw something like this, would this like explain to me what's going on? Another day we're like pair programming, writing that. I had the Bayesian classifiers, like trying looking at accuracies. Another day, you know, talking to Dages, the e-discovery company that we work with, and getting feedback from them, and sort of like listening to lawyers and what their responses were, so that we can incorporate the feedback.
And so you were working with non-technical people on that team,
yes,
right? Like on your client's team. That's exactly. Cool. How long did that whole project take from start to finish?
That took about 2.5 months, I think, the initial phase. But then with a lot of projects like this, we keep communicating and then sort of modifying and supporting it and sort of making little additions, making sure that it actually addresses the problem exactly as it is.
Do you find that in a project like that, that there are like some technologies that you end up learning as you go, or when you went into that project, did you know like everything that you were going to use?
No, definitely not.
Never.
And other people should ask questions too. Use your Q&A app and ask questions.
Yeah, ask a question. No, not ever. And the one that struck me as like the most horrifying when I was pretty new here is so there's this problem when multiple people are working on the same project and they're using like different sets of tools. You have to make sure that all the computers that you're using to work on the project have the same versions of the tools, right? And so that's called like provisioning, and it's a pain. And there are a lot of different tools out there, and we just weren't satisfied with the ones that we had or the way that we were doing it in the past. And someone came into work one day and they were like, you know, I think that we should try this other solution for provisioning. And it was written, it was a Ruby package. And we don't use Ruby. We're mostly Python. But they were convinced that it was the right tool for the job, so people are writing code in a different language to, like, because we think that that investment is going to save time on the rest of the project and make it work out better. But yeah, especially with things, also when we get to making the dashboards or making the visualizations and we want them to look really great, a lot of times we'll end up learning totally new JavaScript packages. I mean, there are things that I've used more than once. But you know, every project has new challenges. Right now, we're messing with getting information out of PDFs in an organized way, and so we're looking at the packages that are out there, and those are all, you know, they all have their strengths and frustrations. But yeah, that's a regular part of the job is getting something totally unfamiliar and just digging into it.
I mean, one of the most important aspects of data science is basically not being scared of all those things that you don't know, because you will not know a lot of things. You will not know most things, actually. Your basis, and if there is something that moment of like, oh no, I have no idea how to do this, you should be confident enough to go and learn it, and you will learn it fast because you already know a lot of other things. But a huge part of, a very important part of data science is just like not knowing and going and learning how to do it.
We Google a lot. In fact, when we were designing the course, I had this like panic moment. I was like, what if they ask me a question and I don't know the answer to it? I'm going to feel like such a fraud. And the answer I got was, well, you'll Google it, and the students will learn that data scientists Google things when they don't know them, and that happens a lot.
Yeah.
So I was like, oh yeah. So it's part of the training when I Google things in class. That's a disclaimer.
Well, it takes a lot to even know what to Google. I feel like that's a certain level of learning when you are good enough to Google something.
Yeah,
no, that's
absolutely.
True. That's definitely true.
Okay, well, people are being shy, so we're gonna move on and talk a little bit about Metis, because that is one of the awesome paths that people can use to learn to be a data scientist. So, can you tell us about maybe tell us about like your path to learning the skills that you needed in order to be a data scientist? Like, it sounds like you both had different sort of backgrounds. Like, how did you learn Python and R and all of these sort of like technical things that you now know? Like, did you do it on your own, on the internet, or how did you sort of approach that?
I mean, my first coding started in graduate school, and I was just writing scripts. It was a process of like, I think both of us experienced that at the very beginning. I'm not really programming, I'm just writing some scripts to get something going.
Mm-hmm. Yeah.
And then at one point you realize, oh, I actually am kind of programming. This is what programming is about. And I was sort of learning statistics from here and there, sort of like on the street, from my, coworkers, from my fellow graduate students, from postdocs when we needed to do an analysis. Oh, okay, this is how you do it. And I've taken some classes, but I've learned both Python and statistics and slowly machine learning over completely separate different projects, picking up one thing here, another thing there, and finally realized
what machine learning is, that term.
Oh, sure. Machine learning is actually, it's kind of a historic term because it's basically learning models from the data, but it's called machine learning because it came from the AI community of, a machine will look at data and learn about it and be able to tell you something about it.
Mm-hmm.
It is basically looking at data, building models that can either predict things or classify things or explain.
Yeah. Another way to put it is if you have some set of observations, right? And observations is another way of saying data. Can you, from that, abstract out some features and learn about the relationships between those features so that you could take a totally new observation and make guesses about what it would be like. And that can take like a ton of different, there are tons of different ways to do it. And I think that one thing that really blew my mind at first, because machine learning was not something that I was familiar with and it sounded very complicated, but I knew what regression was. And regression is just a very simple form of machine learning. Like if people are talking about machine learning, they're usually not talking about linear regression, but it's the same kind of principle, that if I have these weights for these different features, and I sum them up, and I figure out in what way to sum them up, I can make a prediction about what that outcome variable will be. And then you just get trickier and fancier at how you do those things.
Or it can be something like, okay, I will show you a lot of things with a lot of properties to each of them. Find me groups of similar things. Or another way of looking at it is like, I know I can show you, like with the legal documents, these are relevant, these are not relevant. Now I will show you new ones, tell me which ones are relevant, using all the knowledge that you learned from looking at them previously. Mm-hmm. All of this is machine learning.
Yeah, cool. Thank you. That's a buzzword that I feel like it's nice to have you all explain it. Okay, we have a question from Jonathan. He says, I have a BA in math, and I've been confused as to how to enter the field of data scientist. I'm wondering, are programming skills more important than math or stat skills? What do you think?
I would say, well, okay, so as we've been developing this class, I've made this separation between skills and ability, right? So if I think of skills, it's like, what have I already trained up to a certain level? And when I think about ability, it's what am I going to be able to do a really good job with? So I think that for data science, your ability or your acumen for math and stats and programming are kind of neck and neck. Because I think that we do a little bit less heavy lifting in programming, but like we said before, it's just always changing. So you're kind of constantly learning programming. And then, of course, the math and stat skills are really important. And then a third caveat on that is it depends on what kind of data scientist you want to be. So if you're I want to do big data analytics at a huge company in Silicon Valley, you better be a pretty good programmer and know some about stats. If you're I want to, use the open data portal in my city to solve, social problems and help people around me, then you better really understand math and stats, and you better be, competent at programming. I hope that makes sense.
And also, I was talking about data science teams. In a lot of data science teams, different members will have different levels of strength in these, in programming and stats.
Okay.
Some will be more familiar with statistics, others will be better at programming. They all will have, some level of experience in both, but they will just sort of be a team and complete each other. So that's completely fine.
Yeah. When you think about the cohort at Metis that is going to be starting soon, what kind of background should somebody have when they're in order to apply to Metis and be admitted? Do people need to have like some programming skills or like a background in math or stats? And if they don't, should they just like brush up on that before the interview, or what level should they be at realistically?
Yeah, those were really hard. It was actually harder than we thought it was going to be to answer those questions in like a usable way. We have one like hard bottom line, and people have to have some kind of programming experience. We're really looking for like that programming acumen, or we need a sense that you're going to be excited and ready to take off and learn a ton of programming, or to use it every day and to deal with all those frustrations. And in order to really know that for someone to self-assess even that they're ready for that, someone needs to have. I think that what we ended up saying here is like you need to have written code to achieve a goal that was your goal in the past. So if you just like did like a simple homework assignment or did a course that didn't really challenge you too much to like design something, that wouldn't quite be enough. But if you did a couple of classes and one of those had you pick something you wanted to do, make a goal, and then to achieve that goal by writing code, and then to experience that frustration of it not quite working and what's wrong with it, and then fixing it and feeling really exciting and wanting more. If you have that disease where you've gone through coding something once in the past and you want to do it again, and you know that that's the truth about you, then that's like the kind of experience. Now, people, that's not to say that this will be a really remedial program. If you have programming experience, if you have math and stats experience, this is still going to be a big challenge. But that's the interesting thing about people who are interested in data science is they have such varied backgrounds that we didn't want to rule out people just because they didn't have X, Y, or Z in their background. So we have these like minimum requirements for programming, and for math and stats. It's kind of the same thing, to have some background. It could be in academic, it could be through work or through independent projects. And then we ask a few questions that kind of test your ability to think about statistical questions. And they're not really complicated, but we just want to make sure that people are super quick on the uptake and kind of clever. We're looking for clever people to, because it's a lot to throw at someone in 12 weeks, and we have the responsibility to pick students who are going to be able to run this.
Yeah, I mean, I would just say don't be afraid. It's a lot of people will rate themselves really lowly in terms of, like, for example, they will think, oh, I can code a little bit, but I have no idea about stats. What am I going to do? When this is not actually the case, when they are sort of like above that minimum level, and they have enough experience in coding that they can completely get stronger in stats in the class, and that will not matter. So I would say err on being bold.
Yeah, that's what it sounded like, is that people probably have some of the skills already, and they just don't know that that
exactly
kind of qualifies them.
We found people are so bad at assessing, or gauging how good they are compared to other people. People who I've more than once I've talked to someone who had a PhD in physics or something, and they said, I'm just not that strong in stats. And I'm like, wow. I'm talking about normal people strong in stats. Have you taught advanced statistics at a graduate level? And they're like, well, yeah, but I'm not a statistician. So, I mean, it's really hard to get people to give you an accurate or objective assessment of how good they are. So we had to be a little bit trickier and get at it in different ways.
Yeah, and I think with headlines like data science is the sexiest job in the world, and it's super in demand and stuff, people probably don't know if they're qualified, but everyone should have. Cool.
Yeah.
What will the curriculum look like since y'all sort of designed it? We had talked before about the dimensions, and I think that's very unique to this program. Can you tell us about those and how they play into the curriculum?
Yeah.
Sure. So those dimensions are about a data science project, and first and foremost, this is a project-based bootcamp. So everybody will be doing a data science project at all times. We're going to do multiple projects. It's going to be 5 projects, where the last one is like completely for the student to decide on everything. It will help, but
and like the reason for that was like two main reasons. When we thought about building a boot camp, versus something like more academic, if a boot camp is supposed to be maybe a training program, and when I think of training, we think of repetition of something. So if I want to train people as data scientists, what should they be repeating? And to us, that's like a data science project. So if they're going through that project of going through all the dimensions, which Irmak's about to tell you about, and getting that experience over and over, that was what we thought was the best way to prepare them for a job as a data scientist. And then there's a side benefit of that, which is if we go all the way through each project, that means that there's going to be some output at the end. There'll be, a visualization or a report or just something that shows that you've done something. And those can be put together and form like a really rich portfolio. So instead of just having, instead of just telling an employer in an interview that, oh yeah, I learned about this, this, and this, you can show them. And instead of just showing them one thing, you can show them, 5 pieces of what you've been up to.
Right. And the idea is I'd like to think of it as you are almost like hired as a data scientist at the beginning of the bootcamp, and now these are the projects that you have to do at your job.
Okay.
Of course, you don't know how to do all of them yet, but we are there to teach you how to do them. Right. But you still have to do them. It is your job. We are just going to teach you everything you need to get to do that job. So you will have kind of a job experience for 3 months at the end of it. And the domains, coming back to the domains of a data science project, the dimensions, sorry, of the data science projects, we thought of them as the domain of it, where this is about which industry or which area of business this project is about. Because your approach will be different if this is coming from a financial company or I don't know, an NGO or something else. We are thinking about the design aspect, understanding the problem, figuring out the question, coming up with ways to solve it, and that continuous iterative sort of process of figuring out how to attack it. Then there is the data aspect of a project. So you need to acquire data, which data, from where, how to clean it, and how to handle it with databases and stuff like that. There is the algorithms aspect of it. When you're doing the analytical solution to your problem, which algorithms, which statistical tools are you going to use? We talked about machine learning, like which of those fits here or doesn't, or do you need to come up with something completely on your own? Then there are the actual tools. For each of the other dimensions, of course, there's a way of applying them. Okay, you chose to use this algorithm. Well, how are you going to use that? I'm going to use this package or this library for when I'm programming to do that. If I'm using a database, this is the database I'm going to use, and this is the language I'm going to use to interact with it. And then finally, there is the visualization and communication aspect of it, where you continuously talk to the problem that has the person, the person that has the problem, and again, do that feedback and visualize all the results that you have so that they can make a decision based on what you figured out about the problem. They need to understand the solution. So these are the different aspects of a data science project, and each of them will have you.
So as you're going through each project, obviously at the beginning we haven't had enough time to build a ton of skills. So it'll be very guided, and it'll be more about getting your bearings and learning how the process works. And during that time, we'll do some of the introductory lectures. And then each one going through, we'll get a chance to focus more on individual aspects. So maybe in project 3, we're going to maybe that project involves some classification problem. And so we'll spend a lot of time kind of in the morning theory parts of the class, like learning about the different algorithms, and then in the afternoons when we're working on the projects, applying some of those methods that we just learned to the project. So maybe in that one we'll be, for like the communication or for the design, we'll be using things that we'd already learned, or just doing all the same things together. And then we can just like take turns and highlight different places. A lot of this course is designed around my short attention span and just the desire to not bore myself or the students, because I was just thinking about that big chunk of just introductory like programming and stats that felt like it needed to go in the beginning, and I was just like, man, I just want to dig in and do some cool data science right away. And so we were just like, well, what if we insist that that's one of our design constraints, that we're going to get in there and do cool data science right away, and what would that course look like? So it's been such a power trip to be able to design our own class exactly how we want to, and I think that the results are just, when I think about it, it's just really cool, like how it works out and how it's going to play out in the class.
Will people be doing, I love hearing about the projects, will people be doing group projects, or will it mostly be individual?
Both.
Yeah.
Okay.
We'll definitely be enforcing things like pair programming. We have to balance really like the joy of working in teams and how that's like a huge part of my life right now at work, and kind of the terror of your like portfolio depending partially on these strangers you just met. So we're going to feel out exactly where that balance is going to land. I have a feeling that we're going to end up with really great cohort of talented people, and they're going to want to work together. But yeah, and I think that carries a lot of benefits with it too. But each person is going to need to learn all the stuff on their own as well. So there will be, working together, and there'll also be.
Yes, and also when you're actually working individually on your own project, we as instructors will basically be coming and pairing with you for a while. Okay. I mean, of course, we will be like continuously helping and answering questions and all of that, but also, actually spend some, pairing time so that you can actually have that experience with somebody that's already a data scientist.
So cool. When does the Metis program start? And what is there an application deadline or rolling?
Yes, we have rolling admissions. The deadline is August 11th, and that means the sooner you apply, the better your chances. But we will be accepting applications through August 11th. I said August 11th, right? August 11th. And then those close. People have a little bit of time to do their pre-work. And then our first class is the day after Labor Day, which is September 2nd. And then the class ends the Friday before Thanksgiving week. Cool.
That's awesome. Yay. And you'll be in the WeWork space.
WeWork, right. 79 Madison and Nomad. I'm learning my New York neighborhoods. So we're in Nomad, which is near the Flatiron District.
It is. Just on top.
On the island of Manhattan.
Yes. I went by the space last week, and it's really cool. It's a great, looks like an awesome place to learn. So I'm sure that it'll turn out really amazing.
Really excited. Yeah,
we're really excited.
Cool. Okay, if anybody else wants to ask other questions, then this is your chance. If not, then Laurie and Irmak, do y'all want to add anything before we sign out?
Just that if people are feeling particularly shy, but they think of questions later, there's a info at This Is Metis, and you can reach out to us on Twitter as well. We should be fairly easy to Google, and I think it's all over our bios. But yeah, we love answering questions about the course, and we really want to encourage people to apply. Yeah,
definitely.
Wonderful. Well, thank you everyone so much for joining Course Report and Metis for this webinar. Irmak and Laurie, we can't thank you enough for being here. And if you have any questions for Metis that you didn't want to ask tonight, but something pops up, then I will send out all of the contact info after this in an email and with everyone's Twitters and everything like that. And then we're also excited to announce that we have an exclusive offer with Metis for anyone who attends this webinar. Just put course report in the referral field of your application when you apply, and you'll get $500 off of your Metis course, which is huge. It's wonderful. So if you have any questions about course report, please don't hesitate to reach out to me. I will send out a recording of this webinar, so check your inboxes for that. And visit coursereport.com and sign up for our email list, and you'll get future updates about all of our webinars and interviews in the future. All right, so we will sign out. Thanks so much, Laurie and Irmak.
Thank you very much.
Thanks, Course Report.